The next three says consistency and independence of a system of a linear equation is going to ask you for different forms. Is it going to be consistent independent where I have one solution? Is it going to be consistent dependent where I have infinite many solutions? Or is it going to be inconsistent where I have no solution like I did on the previous problem? So on these ones you have to pay attention to which type of system you are talking about. If I have consistent independent, we want to have neither the slope or y-intercept the same. If I'm going to have consistent dependent, then both the slope and the y-intercept are the same. Because that's actually the same line, one line right on top of the other line. And if I'm going to have the inconsistent one, the slope has to be the same, but the y-intercept is going to be different. Right? It still has to have the same slope in order to be parallel, but you don't want it to be the exact same line, so they have to have different y-intercepts. So we have to keep this in mind, and we're actually going to do this problem very similar to the previous one, but now we're going to do two different proportions because we're going to be comparing both the slope and the y-intercepts. And so the first one says, I want to find the numbers for A and B so that I have a consistent dependent one. If it's consistent dependent, both the slope and the y-intercepts have to be equal to each other. So I'm going to start out by solving each of these for y again. So I'm going to say negative 6y equals a positive 2x plus b. I'm then going to divide by my negative 6. Y is going to equal 2 over negative 6 would be negative 1/3 x. And then I have b over negative 6, so minus b over 6. If I do my second equation, I'm going to move my x term to the other side again, so negative 2y equals a negative ax minus 2. I then have to divide by my negative 2. So y is going to equal, I have a negative over a negative, which makes it a positive a over 2x, and a negative over a positive, which makes that a minus 1. So I've got both of my equations solved for y. I am now going to set my slopes equal and my y-intercepts equal. So for my slopes, negative 1/3 would have to equal a over 2. If I cross multiply and solve that, I would say, okay, 3a is going to equal negative 2, so a equals negative 2/3. Then on my y-intercepts, I would say negative b over 6 is going to equal negative 1. So when I cross multiply there, negative b equals negative 6, so b is going to equal positive 6. So a has to equal negative 2/3, b is going to be equal to 6. Now on my next one it says find two numbers a and b such that the following system of linear equations is inconsistent. So if it's inconsistent, the slope has to be the same, but the y-intercepts have to be something different. Again, I'm going to solve it pretty similar to what I did here, so I have to rearrange my equations. 3y equals negative 4, whoops, positive. Better make that a positive when I move that over. Positive 4x plus 5. I'm then going to divide by 3. So y equals 4/3 x plus 5/3. My second equation, 6y is going to equal, that's going to be a negative ax plus b, and then I'm going to divide by 6. So y is going to equal negative a over 6x plus b over 6. So in this one, I want my slopes to be equal. So 4/3 is going to equal negative a over 6. And I'm going to, again, cross multiply to solve. So negative 3a equals 24. When I divide, a is going to equal negative 8. A equals negative 8. Now my b value, I want my y-intercepts not to be equal. So I want to say that 5/3 cannot equal b over 6. And so when I solve this one, 3b cannot equal 30. Divide by 3. b cannot equal 10. When you pick your answer, you're going to pick any number you want to. As long as you don't put 10 in, it's going to be okay. B can't equal 10, so I'm going to say, oh, I'm going to have B equal 0. Sounds good. Now it has a different y-intercept than this line did. Now, chances are, if you just guess some weird number and put in like 9.9, it's not going to be the same thing as whatever that was. So you could do it that way, but just to practice the work, I would solve it and say, oh, it can't equal this number, and then I'd pick anything other than what I got for the answer. Now, hopefully you wrote these things down on the side because I have to move the board to get to number 6. But number 6, we want to do consistent independent, if you know what's here on the direction. Neither the slope or the y-intercept will be the same if you're doing consistent independent. So again, if you were really lazy, you could probably just guess 2 things, and as long as you pick some really weird number, it'd probably come out right. But just to go through the work, if it's consistent independent, we want neither the slope or the y-intercept to be the same. They both have to be different. So in this case, again, I'm going to rearrange and solve. 2y would equal negative ax plus b. So when I divide by 2, y equals negative a over 2x plus b over 2. I solve my second equation. Hey, y equals negative 5x plus 6. I don't have to do any dividing, so I'm already done with that part. So if I'm doing consistent independent, I would want to say negative a over 2 cannot equal negative 5. So negative a could not equal negative 10. A can't be 10. So you pick any number in the world other than 10. Oh, I'm going to say a is equal to 2 then. Whatever number you want to pick, it doesn't matter. Then I'm going to do the other one, and I'm going to say, okay, b over 2 cannot equal 6 then. So b cannot be equal to 12. Again, I can pick any number in the world I want to. Maybe I want it to be 2 again. So both my slope and my y-intercept can be any number in the world I want to pick other than what I got for the solution when I solve them, if I'm consistent independent. So those are the 3 ways you're going to see that. Consistent independent, both of them have to be different. Consistent dependent, they both have to be the same, so whatever I got for my answers would be my answers. And inconsistent, the slope is the same, but the y-intercept has to be something different.